Okay, here are your worked out solutions to the assignment on transformations of trig graphs. Number 1, we have y equals 3 sine of x, graphing over the interval from negative 2 pi to 2 pi, and stating the period and amplitude. Okay, so make the graph. We go from negative 2 pi to 2 pi. Typically, I would make a mark at 1 and a mark at negative 1 on my y-axis, but because of the 3, that means we have a vertical stretch, and that means it's going to be 3 times taller. So we're going all the way up to 3 and down to negative 3. All right, so let's divide our intervals into 4 equal parts. So in yellow, I'm going to draw what the regular sine graph would look like. Normally we would go from the middle to the top to the middle to the bottom to the middle. This would normally be the sine graph. Middle, bottom, middle, top, middle. Okay. So what we're going to do is make it 3 times as tall. So we have middle, top, middle, bottom, middle, vertical stretch. Middle, bottom, middle, top, middle. So the green one is the one we wanted. And then for the period, that would be the width of one cycle. That did not change at all. It's the same as it was originally, so that would be 2 pi. And for the amplitude, that would be the height from the middle to the top, and that did change. The amplitude is 3. Normally it's 1, but we multiplied the function by 3, so we tripled the amplitude. Okay. Number 2. What we're going to do here with the negative is we are going to reflect it across the x-axis. And then because of the 1/3, it's going to be 1/3 as tall, so that's a vertical shrink. So we can go ahead and start our graph, going to 2 pi and negative 2 pi. If this is 1, then I want to mark 1/3. That should say 1/3. And then down here we have negative 1, so we want to mark negative 1/3. All right, split these intervals into 4 equal parts. And this one is cosine. So I'm going to start with yellow, drawing what cosine would normally look like. Normally cosine would go from top to middle to bottom to middle to top, like this. But we want to take that and flip it upside down because of the reflection and shrink it so that it only goes up to 1/3 and down to negative 1/3. So because we're flipping it upside down, instead of starting at the top, we're starting at the bottom. So we go bottom, middle, top, middle, bottom. And then that happens on the other side too. Middle, top, middle, bottom. So that is a graph we were looking for. And for the period, we did not change the width at all, so that is still 2 pi. And for the amplitude, we did change the height, so the distance from the middle to the top is now 1/3. Number 3. We have a sine of 4x, and when you multiply by a number inside the function, that's going to be a horizontal change. Remember, I would call this one 4 times the fun. If it was a roller coaster, it would be 4 times the fun. That means you have more curviness, so it's going to be a horizontal shrink. So you can think of it as 4 times narrower than it used to be. So here's 2 pi. Here's negative 2 pi. That means we're going to get 4 times as many curves in the same amount of space that we normally would. So if I break this down into 4 equal chunks, this one is at pi over 2. This is pi. This is 3 pi over 2. We need a height of 1 and a height of -1. Normally, this is what the sine graph would do. Normally, the sine graph would go middle, top, middle, bottom, middle, middle, bottom, middle, top, middle. So the yellow one, that's what a regular sine graph would look like. But what we're doing is we're making 4 times as many of those. So that means in the space between 0 and pi over 2, we have a complete sine graph. So that's going to look like that. 1, 2, 3, 4 of those. And then 4 more on the other side. 1, 2, 3, 4 of those. Okay. So then, what's the period? The red one here is the one we were asked to graph. What's the width of one cycle? The width of one cycle is pi over 2. That's the space, the horizontal space it took to do one complete curve. If you take the normal period of the sine graph, which is normally 2 pi, and you divide it by 4, you get this new period. The amplitude did not change. It's still going up to a height of 1 and down to a height of 1. So the distance from the center to the top is still 1. Number 4. Here we have a negative in front. So that means we're going to reflect it across the x-axis. And we have the 2 as well. And that means we're going to stretch it vertically twice as tall. And then inside the function, we have a 0.5. So we would say that this roller coaster is half the fun. So that would be a horizontal stretch. It's going to be twice as wide. That's what makes it half the fun. All right. So 2 pi, -2 pi. We're going to need to go up to a height of 2 and down to a height of -2. Let's divide up the x-axis. We're dividing it into 4 equal chunks there like we normally do. The normal cosine graph would look like this. Top, middle, bottom, middle, top, middle, bottom, middle, top. That's what cosine would normally look like. Now what we're doing is flipping it upside down, making it twice as tall, and making it twice as wide, because it's half the fun. So you don't necessarily have to do all those things at one time. Flipping it upside down and stretching it twice as tall. So we're going to start at the bottom instead of starting at the top. And then we're going to get to the middle twice as far out as we normally would. And then we're going to get back to the top twice as far out as we normally would. And same thing on the other side. So we get this. Okay, does it look like it's twice as wide? Does it look like it's twice as tall? And does it look like it was flipped upside down? So for the period, it's twice as wide as a normal cosine graph, so the period is going to be 4 pi instead of 2 pi, twice what the normal period is. And then for the amplitude, it's twice as tall as a normal cosine graph. It doesn't matter that there's a negative there. You don't have a negative amplitude. Amplitude is just the distance from the middle to the top, so that's just always a positive. And in this case, that's going to be positive 2. Number 5. We have here a vertical stretch because of that 2 right there, twice as tall. And we also have a vertical shift up 2 because of the +2 at the end. So twice as tall and up 2. Okay, so I'm going to give myself more space here on my y-axis, going to 2 pi and -2 pi. Let's divide that into chunks. So the midline is normally at 0. Now the midline is going to be at 2. So I think it's really helpful to draw in the midline. And then what we want to do is make our sine graph go up 2 units from the middle and down 2 units from the middle. So we have start at the middle, start at the, like normally we would start at a height of 0, so we shifted that up, started at a height of 2, and from there we go to the top, to the middle, to the bottom, to the middle. Same thing on the other side, to the bottom, to the middle, to the top, to the middle. Okay, so that is y equals 2 times sine of x plus 2. What's the period? So we did not make it any wider or narrower, so the period did not change compared to the original. It's still 2 pi. What's the amplitude? It did get taller. From the distance from the middle to the top is now 2 instead of 1, so the amplitude is 2. All right, there you go.